I'll quickly show the distribution of ADMET risk scores for this set of compounds. We observed that about 90% of orally bioavailable commercial drugs have an ADMET risk score of 7 or less. So these compounds all have relatively low scores. If I view the histogram of risk rule violations, you can see what those are for this set of compounds. The dominant one is labeled KOW, which is octanol water partitioning. So these would be the compounds that have relatively high predicted log P or log D values. You can, of course, modify our ADMET risk rules, or you can create entirely new risks, risk models on a project-specific basis. Okay, there isn't a lot of time to discuss individual predictions at length, but I want to focus for a minute on our pKa predictions, which are very highly regarded. These were the top performing QSAR predictions in the recent Sample 6 pKa challenge, the results of which were just published in the Journal of Computer-Aided Molecular Design. I'm just going to show the columns of the macroscopic pKa predictions. In addition to these, you can also see predictions of the individual ionization microstates for a given compound. And I'm going to just quickly illustrate that using a compound that has both basic and acidic groups. I'll do an exact search. So with this compound selected, if I launch our pKa microstates viewer, just magnify that a bit, our macroscopic pKa predictions are listed here in descending order. So you see that at a pH above about 4.2, we predict the single fully deprotonated species. And then in this pH region, for the zero charge state, we predict an equilibrium of multiple microstates. The dominant one being fully neutral and the others being zwitterionic. We provide estimated populations for these microstates, which you can also view as a function of pH. So this chart represents all of the ionization microstates, and you can also view the corresponding macrostates. So this would be the -1 charge state here, the 0 charge, which is the sum of these microstates, the +1 charge, and so on. Related to ionization, we have features to predict log D and solubility as a function of pH. So for that same compound, I could show the predicted solubility curve, and it's the characteristic zwitterion shape where the minimum solubility is in the pH region where the compound is predominantly neutral.